Hello, let us talk about different logic families used in digital circuits. So basically, if you see, um, we generally used in designs the integrated circuits. So the integrated circuits are made up of a number of logic gates. So these logic gates are formed using a basic circuitry. So this basic circuitry, which we can call them as a, a family, where it could be a TTL or Cmos. There are different kinds of logic families. So they constitute the basic level circuitry, and the performance of this integrated circuit entirely depends on these logic families. So in our application, based on the requirement, an IC with a specific logic family shall be selected. So example, if you see, an IC could be from a CMOS logic family or from a TTL logic family. Based on your requirement, which we will see a comparison between these logic families in the next slide, you select your integrated circuit in your application. So if you see, this is the basic comparison. The logic family are of different categories. One of the major category which we know is the TTL. So we are all aware of the TTL logic family, and then the CMOS logic family. So most of us might have heard about this, but other than this, there are other logic families like RTL, which is a resistor transistor logic, the diode transistor logic, the emitter coupled logic, and high threshold logic, or the integrated injection logic. So if you see, there are some parameters which we listed here on the left. So these are some of the major parameters which define the kind of family that can be used in a particular application. For example, if you see the power dissipation, everyone knows that CMOS have the lowest power dissipation among all the families. So if you see here, integrated injection logic in fact has the lowest power dissipation, but CMOS, because of its other advantages integration wise, the power dissipation is, even though it is higher than integrated injection logic, this is the mostly preferred logic. So when it comes to power dissipation, CMOS is the highest. CMOS is the preference because it has the lowest power dissipation. And then after CMOS stands the TTL, and then comes the DTL, which is greater than TTL, and the RTL. So this is the preference when you talk in terms of power dissipation. So now one can say, we can give a figure in terms of wattage or microwatt or milliwatt here, but the thing is, it depends on your circuit configuration, the kind of add-ons that you have with respect to these circuits. So talking at a very high level is a good choice, because in terms of figures, this could be little confusing with respect to the usage, because in reality, when you say, example, a CMOS has a specific power dissipation, it might not be practical, and you might not see the exact value. So comparing between different logic families is the best way, where what we have done here is, if you see, the integrated injection logic has the least power dissipation, and then the CMOS has higher power dissipation than this, and if you come here, the TTL has higher than. So we have arranged this in terms of ascending order of power dissipated within the family. And then when we come to the propagation delay here, ECL is the best choice. So if you talk about high speed board designs, so ECL logic is the most preferred logic, and that is why you see most of the ECL logic being used there. And then there is one more parameter which we have mentioned here called the fan out. So CMOS has the highest fan out among all the families. So if you see the comparison here, it has the lowest power dissipation, it has the highest fan out among all the families, and then power dissipation wise also, if you see here, it's not too high. So that is why you see that CMOS being used in many of our ICs. So if you see a specific IC data sheet, it starts with saying CMOS integrated or CMOS based MOSFET or whatever. So or CMOS based gates. So basically what it means is CMOS is most used logic, digital logic. So there are several extensions of this CMOS which are coming up, but we just want to restrict this to a very high level of logic circuits. And then when it comes to noise immunity, so noise immunity is nothing but the performance of a particular logic family under noise conditions. So if the logic family performs better under noise, that means it has good noise immunity, that means it is able to perform. So if you see that conditions, ECL and then IAL has the poor noise immunity, whereas the TTL and CMOS which we use regularly have a good noise immunity. And if you see here, the TTL basically, if you see the evaluation of this digital logic, so in the initial days there was more of RTL, and then the DTL came up, and TTL was one of the mostly used. Later, based on the high speed board designs or based on the power requirements, the ECL and the CMOS came up. So that's how the evolution of these digital families came up. And to control some of the important parameters with respect to the noise immunity, a HTL, high threshold logic, has come up from the DTL logic. So HTL is nothing but a modification of a DTL logic family. So that's why if you see here, most of the parameters are similar to the DTL logic. Now, if you just come down, this is a glimpse of the digital logic families. So this RTL, if you see resistor transistor logic, is a combination of a transistor and the resistor input. So if you can see here, there can be number of inputs connected here. So the resistor transistor logic is a combination of resistors and transistors. Now if you remove these resistors and connect the diodes, it then comes the DTL logic. So here the input is provided to the diodes. Now if the diodes are eliminated and if you provide the transistors in that place, that is called the transistor logic, where you have the inverter at the output, but the input is provided to another transistor. Now one of the other configuration, which is the differential amplifier configuration, which is used in the operational amplifier circuits or the high speed requirements, is the ECL, emitter coupled logic. That's what it is seen here. And finally the CMOS. CMOS is based out of MOSFETs. Here if you see, this is a combination of a P channel and N channel, which works as one of the inverter circuits. So this is a CMOS circuit. So this is how the evaluation of logic families happened, and the configurations are being maintained, or the evolution happened based on the user requirements, whether he wants the lowest power dissipation or he wants the highest speed, so such that the propagation delay is lesser, or whether the noise immunity is the preference, or if you want to connect more number of outputs for a particular node, that which defines the fan out. So based on these, you select your logic family and use it in your application. So if